Hey YouTube, what is going on? Welcome back to my channel. We're gonna be solving the blind 75 questions on Leetcode. It's gonna consist of all algorithms and data structures, so stay tuned. Okay, so as I said, I'm gonna solve like the blind 75 questions on Leetcode, and you may or may not have heard this term, but it's essentially a combination or a set of 75 questions from Leetcode that it's considered that if you do these, you're considered pretty well versed in algorithms and data structures. So I'm just gonna go through all of them. So you see them here, they're all arranged in little categories where you have arrays, binary, dynamic programming, graph, interval, linked list, matrix, strings, trees, heaps, and then something at the very end. So I'm going to go through all of these. I've done some of the beginning ones already, but I'm going to go through them anyways. Again, like if you want to follow along or do this on your own and then watch this video so we can compare, that will also be a great way to follow. Okay, so the first one is to sum over here. So this one's easy. I think this is the first question on Leetcode 2. Yeah, it's like number one. So given an array of integers nums and an integer target, return indices of two numbers such that they add up to the target. So you may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. So over here, I'm going to do this all in Golang, by the way. That's one of my primary languages. So I do Golang or JavaScript. And for serious algorithm stuff, I really want to use Golang instead of JavaScript, even though I guess JavaScript makes things a little bit easier. Okay, so we have our nums over there, which is an array of integers, and our target, which is an int. So now first and foremost, the easiest way is to just make a for loop, and then you iterate over each element in the array, and for each one you iterate the other ones afterwards. So for example, over here Golang has this neat little quick little operator range where you can iterate over nums. So you can say I is num1, and then for j num2 in range nums. So this is a double of a for loop that you would do in any programming language. Num1 and num2. So it says you may not use the same element twice. So we do want to skip the iteration if they are the same indices. So if I is equal to j, then we want to continue. We don't want to process this. But if they are not equal, then we got to see if they equal to the target. So if we say total is equal to num1 plus num2, and then if total is equal to the target, we want to store those indices. So if we see the example here, the target is 9 and indices 0 and 1 add up to 9 over here. None of them add up to 9. So the second example, our target 6 and indices 1 and 2 add up to 6, and over here target is 6 again, and indices 3 or indices 0 and 1 add up to a 6. So what do we want to do? We want to store these results in an array, so we declare it like this. In Golang we make an slice of integers, be more precise, and then we go slice is equal to append res, and then we want to store those two indices in I and j. I'm trying to think whether there's any duplication that happens. Let me just return the results. Let me think if any duplication happens within this. For I nums we move on, I nums 2 we move on. No, I don't think any duplication would happen. So let's see, let's run this code. I think it should pass for the basic case or for the first one. Oh, okay, duplication does happen over here. So we do want to consider that. So I and j, oh, okay, we want to take the next indices for here. So what we might have to do is for j is equal to I plus 1, we actually might have to make a for loop for this, equal to nums, and then j plus plus, and then we can remove this for loop over here, and we just want to put this in here, move this stuff in here. And now we don't have nums2, we have to do nums at indice j over here, and we want to close this. Let's run this, see if this compiles first. Okay, so there it passes, and with a runtime of 0 milliseconds, so that's good. Let's run the rest. So if we submit this code, these are all my past results here. Okay, so this is a double for loop example. What usually happens is that double for loops have the best memory allocation or in the top tier, but they're always one of the worst when it comes to run a time. So one thing with a double for loop is in most cases where you're using a double for loop, you can most likely use a map to speed it up, because you can store the results, because you're sort of iterating through everything twice, which is the double of a for loop. So there's another way to do this is, let's clear this all up because we don't need all of this, but we do need a map. So for the lack of bad naming, I'm going to say a map set we want to make a map where the key is going to be the target, and then what it's gonna return is the the index for that target. Now, if that doesn't make sense, let me code this out a little bit more. So we still need one for loop to do this. So let's just say I is equal to n range nums. Okay, so what we want to do is this is how we're gonna solve this. So for all these examples, we know the target, and let's say we have one for loop here. So if we go over the first indices, we know what number indices 0 needs to have to add to 9. And the way we do that is we take 9 minus 2 is 7, and we know for indices 0 it needs a 7 to qualify. So based on that, we can sort of try to find where the 7 is. So this is what I mean by that. So if we say needed is equal to target minus n, so that's what we need. So what we're going to do is we're going to check our map set whether needed exists. And so the way this works is I'm going to say index, and then maps return, in Golang maps return an OK, which is a boolean, which lets you know if it's found. So if it is found, then we want to do two things. We want to add the two indices in that. So res is equal to append. Oh, my battery is running low. Append. Let me plug this in real quick. Okay, laptop's charging. That's a close one. So we want to add those two indices, right? So we want to add indice I and indice the one that is returned from the map set. Otherwise, if it doesn't exist, then we want to add it to our map set. Um, Otherwise, what we also have to do, actually at the very end, let's close this for a second. At the very end, we do want to store it. So map set is equal to needed. And then we want to store the indice that it was on. So for this indice over here, we need this. So that's what it's essentially saying. Let's run this code over here. So this one doesn't pass because that's what we need. Target minus n. Okay, so I changed up the code over here. I'm not exactly sure what went wrong because the code is exactly the same, but essentially now we got the test case passing over here. So if you see what's going on, let's say I'm at indice 1 over here. I'm doing target minus 2, so 9 minus 2 is 7, and I'm checking if 7 exists in the map set. Now in this case, since it's the first iteration, it doesn't like nothing really exists in the map, so we're just going to store that, hey, this indice needs 7, so that later on when we iterate through the array and if we find a 7, we know that, hey, indice 0 needs a 7, and we store both of that like we have over here. So we submit this over here. Let's see what we get. We should get something faster. Yeah, so we get 13 milliseconds now. This runs in, which is faster. And I wouldn't get hung up on this too much. This is one of the better solutions out there. And Golang's pretty fast anyways to begin with. Let's see what else we have. So this is the first question. Now the second one is best time to buy and sell stocks over here. So let's read this. This one's an easy one. So you're given an array prices where price at indice I is the price of a given stock on the ith day. So like first 0 day, I guess 0 day, first day, second day. You want to maximize your profit by choosing a single day to buy stocks and choose different days in the future to sell stocks. Return the maximum profit you can achieve from the transaction. If you cannot achieve any profit, return 0. Oh, okay. So essentially, we're just trying to see the highest and lowest value, I guess, right? So here are the prices. Um, and the highest price you can buy is buy on day 2, price 1. So this is day 2 over here. Oh, and then the future we will have to sell. Oh, yeah. So you can do like 7 minus 1 because you can't buy and sell in the past. Note that you buy on day 2 and sell on day 1 is not allowed because you must buy before you sell. Okay, that makes total sense. So this one is a little bit, this one is one of those max and min problems. So the tricky part is we can't get the absolute max and the absolute min for the entire indice. We only have to do it after we find a min. So that's going to be an interesting one over here. So what we definitely need is still a iteration over here. So a range for prices. So, and then if there's no profit, then we can't really maximize on that. Let's see. So for the lowest day, so for each indice, I need to find what profit I can make in the future. That's essentially it. Right, for this indice, what's my maximum profit I can make? For this indice, what is the maximum profit I can make? For this indice, what's the maximum profit I can make? And obviously, I can't really deduct if something is, if all the numbers are bigger. So I can do the double for loop case over here. That would also work. Okay, so max min, and then what's the thing? The return the max profit. So let me say profit over here. So for this indice, max and min. See. Okay, so let's do the double for loop case for now, and then we can do the other case later. So range prices. Actually, I can't even do this because I need to use a regular for loop, because I plus 1 and then j is less than prices len, and then j plus plus. So over here I want to say len. I don't need an extra this. Okay, so I just need to put I over here. So essentially what I'm doing is, first I'm seeing if n1 is less than, yeah, it has to be less than, yeah, if n1 is less than prices at indice j, then only I should calculate if there's a profit. So I can say p is equal to price j minus n1, and if p is greater than the existing profit that we have, then we want to do profit is equal to p, and then we essentially want to return profit. I guess we don't need these max and mins. Maybe we might need it later for the more optimized solution. Let's see if this passes. Line 21. Oh yeah, I'm missing this. Price. Okay, it's prices. Prices. Okay, so yeah, so our maximum we can make is 5 because 6 is the max over here, and 6 minus 1 is what we want. Our constraints are that price has to be greater than, has to be, oh, price is 0. Maybe that's something we can work with, but let's submit this over here. Oh, time limit exceeded. Okay, so that's not good. Another method that I found which requires a left and right pointer. I don't know if this would actually work, but let's give it a try. Right is equal to length of prices minus 1. That's our last indice, and that will be 0. So essentially what we're doing is for L is less than right, and we're going to see whether those two are equal. So we get n1 is equal to that, and n2 is equal to prices at right. And if, so in this case, if this pointer is if this is greater than 4, then there's no way that's possible, so we want to move that up. Yeah, so let's say n1, if n1 is greater than n2, then we want to r plus plus, and I'm going to say continue, else if n1 is not greater than n2, so then we have a chance of buying and selling. So we can say p is equal to, actually then we don't need this continue over here. We can say p is equal to we could say p is equal to n2 minus n1, right? And then if p is greater than profit, then we say profit is equal to P, and then we return profit. So let's run this code. Something is up over here, no new variable on left side. Oh yeah. Oh, another thing is that if profit is greater, then we want to move the left one by one. Oh, we want to subtract that, so we're going down. So the right side we're going down, so we have to subtract. The output is 0. Let's figure out why. If n1 is greater than n2, oh, so if n1 is greater than n2, I think we want to add, and over here we want to subtract. Yeah, output is 5. Let's comment this out, and let's submit this. Wrong answer, output is 2. Okay, so here's another solution I found. I kind of coded it out and then figured it out later. Essentially, you just want to start at your minimum price. You want to assume your minimum price is your first one, and then you want to check the one after. Now, if the one after is less than your min price, then you move up your min price to this value over here. Now your min price is here, and then you're checking number of 5. So now 5 is, or 1 is less than 5, or your min price is less than 5. So you keep subtracting and seeing what your max profit is. Over here it's calculating your max profit. So you're keeping a track of your min value while going up the ladder. So over here in this case, how it will work is you start at 7, and you realize that the min value is 1 down, so you don't really do anything, and your min value is again 1 down, min value again is 1 down, and your min value again is 1 down, and your profit's going to be 0 because you never really found a min value that you can use. So now if you submit this, let's see what we got. We got a runtime of 282 milliseconds. That's faster than 25% of submissions, and about 60% better than most memory usages. So that's the first two of these over here. I hope you found this helpful. I'm gonna try to cut it down to do about 2 to 3 of these per video, and we're essentially gonna go through them one by one to try to solve all of these. If you like this video, please let me know in the comments section whether you want me to continue this series. I'm definitely going to do this because I think it's going to be a great exercise for data structures and algorithms. But let me know what you want to see. If you have any interest, I can definitely do that. I can take a look into that. But in any case, I will see you in the next video. Peace.